first derivative test. That's where we're going to get started. I'm going to grab my notes. So you can start filling in. So our first derivative test tells us when our graph's increasing and decreasing. Excuse me, gentlemen. Shh. Do you need to be moved? Okay. So it's going to tell us if our graph is increasing and decreasing, and it also tells us where our local min and maxes are. That's our first derivative, right? So for example, when we're given a position time graph, we can look at the derivative. If it was a positive slope, it's increasing, negative slope, and so forth. So when our derivative is greater than 0, the slope is positive, and the function is increasing. Vice versa. If our derivative is less than 0, our slope is negative, and the function is decreasing. So this is a lot of review. Critical values are when we have a horizontal tangent, right? When our derivative equals 0. Okay? There's another place that we have a critical value, is when our derivative is non-existent, does not exist. Okay, or undefined. So when it doesn't exist, it could either be asymptote or a cusp or a kink or all those good things. And it will help us get our, draw the graph. If we know that you can't derive it at the point, usually it turns out to be an asymptote. Okay, so first derivative test is going to give us our critical values. So let C be a critical value. The function is continuous. So assuming it's continuous at C, if our derivative changes from negative to positive, what does that mean? Negative to positive. Then at that point C, we have 0 slope, and is it going to be a max or a min? A minimum. So whenever it goes from negative to positive, we have a minimum at C. Min, mum. I'm just trying. Thank you. I tried going backwards and it threw me all off. And then I put an A for an I. That's better. Okay, so if our derivative goes from, so here my slope is positive to a slope or a derivative that's negative, then we're going to have at C, what will C be? A maximum. Okay, if your derivative does not exist, does not sign change, then it has no max or min. So if there's no sign change, then no max or min. So an example of that would be a cubic. Yep. So at cubic you have, so this could be still a critical value, this in this graph, because the slope is 0 there, right? At C here the slope is 0, but on both sides it's positive and positive, so it's not a minimum or max. There literally has to be a sign change. Literally has to be a sign change. Okay? All right, the fun stuff. Good to go? Nope. Yeah? Okay. So if our graph or equation for f of x is negative 2x squared plus 12x, use 2 points to verify, guys, that our function is increasing when x is less than 3 and decreasing when it's greater than 3. Okay, so what tells us increase or decrease? It's our derivative, which is negative 4x plus 12. So we want to verify that less than 3, it's increasing when it's less than 3. So how can I verify that our derivative is increasing less than 3? How could I do that? Plug in a number less than 3. So 2. 2 is less than 3. So let's find the derivative at 2. What does that give us? A positive or a negative? A positive, so therefore increasing. Positive slope. And we want to verify that when it's greater than 3, it's decreasing, so we'll try 4. Which gives you negative 16 plus 12, or a negative number, so therefore decreasing. Let's find the intervals of increase and decrease. So how do we find the intervals of increase and decrease? So remember interval notation, it's like the values of x, right? When for x are we increasing and decreasing? How do we get that then? So what tells us increase or decrease? The derivative. Does this seem really boring after applications? Yeah, kind of, right? It's kind of a nice change though, maybe. Okay? So 8x, yes, it is. Minus I am obviously pulling a Johnson. Okay, minus 18x plus 60. What are we going to do from here? What do we have to determine before we can see our intervals of increase or decrease? When does our intervals change from increase to our critical values? So how do we get our critical values with this guy? Factor. Factor out 6. And then two numbers and multiply to 10, add to negative 3. Two and 5? No. It has to be. Oh. Can we change the question? No. I forgot there was a minus sign there. I forgot to change it on your notes. Now can we do it? Okay, there's
Usually what I do is I'm like, what? You can do that? What? Why don't teachers do that more often? They're always like, hey, it's like,
because I use a white pen. Okay, sorry. Thank you. So they pay me the big bucks. Okay, so x minus 5x plus 2. So our critical values are when our derivative is set to 0. So when is that? What are values of x? So critical values, 5 and negative 2. So we have to do what? Interval test. Woohoo! Okay, let's plug her in. So here, let's try a number less than negative 2. Okay. Negative 10 minus 5 is a negative. And negative 10 plus 2, a negative. So two negatives, positive. Then I try 0. 0 minus 5 is negative. 0 plus 2 is positive. That'll give me a negative. And then greater than 5, so 10 maybe. Positive and positive give you a positive. So when is it increasing? So increasing from infinity to negative 2. Open or closed? Open. Union. 5 to infinity. Decreasing. So it's little things like that you have to be paying attention to in this unit. Just got And then decreasing from -2 to +5.
So what is it doing at
Those are it's a cubic function, so that would be your local min and maxes, where your slope is 0. So if we were to roughly sketch this, it's opening good old polynomials unit. Okay, you guys just finished. So the leading coefficient is positive on our cubic, so quadrant 3 to 1. And so at 5 would be 1, so -2. I don't know exactly where our zeros are. So it's a cubic, right? So that's where, however it looks, that's where, right? So positive slope, negative slope, positive slope.
I get it.
Right? So increasing, positive slope, decreasing, negative slope, It's what? So those are your critical values. So it's I don't know. I just roughly sketched it. Oh yeah, this is the expanded. I don't know. I don't know the actual zeros I said. I didn't solve for the actual zeros. Well, all that is important. Forget the like where this blue thing is. Right? Doesn't matter.
Wait, what is it? Oh yeah, it's like the
Right.
last question.
Just
Math test where
all that matters, because I don't know right now. I'm not putting in the work to find out my zeros. I'm just saying, okay, so at 2, -2 is where I have a 0 tangent slope. It's a local min or max. Okay. Okay, state the domain of the function state the domain over which the function is increasing. Okay, let's go. F of x equals this guy. So to see where they have a positive slope, we have to do what? Jonas? So if we want to find out where the function is increasing, what do we have to do to our function to figure out where it's increasing? Pardon me? I missed that. No? Anyone? Find the derivative, set it equal to 0. Okay, so guess what we're going to have to use to find the derivative of that? Chain rule. Vincent, can you not have those in here? Thanks. So chain rule times 2x. And we're going to set our derivative to 0. So we have 12x times x squared minus 4 to the 5th. What's my critical values? X equals 0 and 2 and -2. Okay. Oh, should probably go like that. -2, 0, 2. And this is f prime of x. Okay, let's start with a number less than -2. -10. Okay, let's do mental math. So I'm going to stick to small. -3. Okay, because I'm going to have to square this sucker. Okay, so 12 times -3 is a negative. -3 squared? Positive 9 minus 4 is +5, and to the power of 5, still positive. So that would be a negative there. A negative times a positive. Okay, now let's try -1, because we need something in between. 12 times -1, negative. -1 squared, +1 minus 4, negative to the power of 5 is still negative plus. Okay, okay, 1, I'm going to do 1. 12 times +1 is positive. +1 squared minus 4 will give you a negative. So this would be a negative here. And then above 2, 3 is positive. 9 minus 4 would be positive. Are we okay? Just tired? Okay. You're not. I just... I didn't know if you're freaking out. Okay. Okay, so over, where is it increasing? Increasing when? Okay, between -2 and 0, union, or 2 and infinity, and beyond. Okay. So our steps are, what's the first thing we did? Derive. Find the derivative. Find f prime of x and set equal to 0. Find what? Find CVs. Okay. Then we placed CVs where? Boys, do you want to leave if you're too busy to be here? Where do we place the CVs? On the number line. And then we tested them, right? And then state the interval solution. Okay, so here, I'd like you to try this guy. I kind of give you the graph, which is kind of like cheating. Should have gave it to you. But find the intervals of increase and decrease. Oh, yeah. Okay. Increasing when? Union. 0 to infinity. Okay. Is it ever decreasing? No. So not all critical values are going to be local max and mins. Right? That makes sense. So just because it's a critical value doesn't mean it's going to be a local max or min. Alrighty, try the next one on your own. So number 5 here, you should have found your derivative first. Set it equal to 0. And factor, we could factor x squared out. So your critical values were 0 and 3 over 4. Oops, I might have an equal sign there. It might help if you start to label this. So we're doing an interval test for our first derivative, just because we will be doing certain questions where you have to do an interval test for a first derivative and then an interval test for a second derivative, so you know which one's which. Okay, so you should have negative squared will always be positive, and then -1 would make this a negative, so you had a negative there, and so you did a quarter, I guess. So you're between 0 and 3/4, or a half. Yeah, half would work. So half squared is positive. 4 times a half. 2 minus 3 is negative, so negative. And the last one, I don't know, 1. 1 squared is positive, and then 4x minus 3 would be positive. And so the local max, so here, this critical value wasn't a local max or min, because it has to change from increase to decrease. Helps to draw the little arrows. So if this is decreasing here and then increasing, we have a local min. So you can kind of see. So local min at, when x is 3 over 4, guess what we have to figure out what y, we need to determine what y is now. What point? Oh, it just says the values. Okay. But usually we do want the point. So if I said find the point, so it's at f, local min at f of 3 over 4. So So we plug in 3/4 into that guy. Do you want me to just tell you what it is? Okay, I didn't think you'd fight me on that one. Negative 27 over 256. So can you do the same thing for this guy? Or do you want to work through it together? Actually, we should work through this one together. Yeah, this one, there's some notes I need to add to the bottom. Yeah. It's like a cubic. Right. Okay, so let's work through this guy because I want to add some notes to it. So first step, find the derivative. So you should be able to do that on your own. So at least go and find the derivative for that guy. Product law, right? Chain and product. Guess what we have to do after we derive? We factor out 1 minus x squared to the negative 1/2. So we're going to have one of these minus x squared. Or if we rewrite this, on our numerator we have 1 minus 2x squared all over the square root of 1 minus x squared. Okay, so there's two places that we have critical values. So the first is our numerator. So when our function equals 0 is when 1 minus 2x squared equals 0. So when would that be? Well, we need to solve that. It's pretty. What would it be? So add 2x squared and divide by 2. So you get x squared equals 1/2, or x equals plus or minus the square root of 1 over 2, or 1 over root 2. It's an ugly guy. Okay, we also need our critical values. So when our derivative is undefined, how do we figure out when our derivative does not exist? When the bottom equals 0. So that would be when the root of 1 minus x squared equals 0. So basically the inside of our square root has to be equal to 0. So that's when 1 equals x squared, or plus or minus 1. Yeah. Right, so our function only begins where? So, well, when this is greater than 0. And that's the note I wanted to write. So since, I wanted to write a note in here. Since 1 minus x squared must be positive, the domain of our function is what? Well, if here's negative 1 and here's 1, and our function has to be positive. So where would our function be positive? When would this give me a positive value? So let's check. So if I plug in negative 2 in here, 1 minus negative 2 squared Negative 2 squared is positive 4, so 1 minus 4 would be a negative. So does it exist there? No. If I plug in 0, does the function exist within here? Yeah. So it only exists in here. Right? So that's the domain of our function, because otherwise you can't square root a negative number. Open. Yeah, it's open. Because at those points, those are 0. You can't divide by 0. So our function is actually negative 1 to 1. Okay, so let's do our interval test. So when we actually do our interval test, we don't even have to test left of negative 1 and greater than positive 1. You would have found that out if you didn't think of this, because you would have got undefined. Doesn't exist there. Okay, we also have critical values of plus or minus 1 over root 2. Now these are the worst for interval tests. The absolute worst. You know why? We have to use decimals.
I love decimals.
Oh. Oh, well that's good then. But you just have to remember what root 2 over 2 is. It's 0.77 something, I think. Well, it's root 2 over 2 when you rationalize it, right? Or 1 over root 2, same thing. So what does that equal to? Yes! Oh, so close. So close. Okay, so then you need to find a critical value that's between negative 1 and negative 0.707. Yeah, negative 3 over 4, or negative 0.75. So you're using a decimal in your critical value test. So now I go back to my derivative, and we're going to do our test here. Okay? I'm just going to use my calculator, whether it be scientific or whatever. And I'm going to use negative 0.8 maybe, actually, because I just one decimal place. You can use a fraction if you want. I don't want to. So negative 0.8, well, guess what? When you square, it's going to come out positive. And so that gives me a negative on top. Let me subtract 1 from that. 1 minus that. So negative divided by, I hate these. Now my denominator, root 1 minus, well, it has to be a positive here, right? I don't even have to test that, because we know that the domain for the function is between here, because that's when the function here is positive. But you can test it if you want. 0.8 squared. Let's give you a positive. Right, that would be a positive value. So a negative divided by a positive. So it's negative here. Now we have, what's the easiest number to test here? Probably 0. Would probably be the easiest. So 1 minus 2 times 0 squared would give you a? On the numerator, if it's a 0, it would be negative on the numerator.
1 minus 0.
No. Oh. Yeah. You're right. Sorry. Just not having a good day here. Okay. The 1 would always be positive. 1 minus 0 squared. Also positive. 2 positives would give us a positive. And now we use 0.8 or something. We do our test again, which wouldn't change. It would be the same as this result, because wherever we put it before, we squared it. So it would be the same. So negative over positive, so it'd be negative. Whew, kind of love that function. So the function doesn't even exist here. And you would have found that out because you would have had undefined for error. Oh, it's so much easier, graphing calculator. Okay, so when the question was find the local max and min values. So we're not done. Our function's decreasing, increasing, decreasing. So what is this?
Minimum.
Minimum. So we have a local min at f of negative 1 over root 2, which equals, we have to figure that out.
Oh, yeah.
Right? So let's go back to the original function. You're going to use the graphing calculator. times 1 minus negative 1 over root 2 squared. This is to the half. So that gives you, no it does, because this is a half, right? 1 minus a half is a half. This is root 2. And this is to 1/2 or a square root. So you get negative 1 over root 2 times 1 over root 2, which is a half. Negative a half, sorry. See? What? Guys, stay here. Let him. Okay, you're punching in the next one then.
I got it. Isn't it going to be positive?
Negative, because the negative on the outside. Okay, and it's the same idea for the next one. It would just be a positive 1/2 for the next one. Is that what you meant? Yeah. Okay, so then we have a local. So this was a min. This is a max, boys. At f of 1 over root 2, which equals a half. Okay, so when we actually get to the graphing components, you're going to figure out the local min and max, and then we're going to actually plot those points. We also have to figure out other things, but that's part of it. So you'll have to know when it's increasing, decreasing, when is it concave up, concave down, critical values, inflection points, all that good stuff. Okay, so here's the thing, guys. The homework's here, but I want to talk to you about that. So pause.